A linear equation written in the form y equals mx plus b is said to be written in slope-intercept form. The graph of this equation is a line having slope m and y-intercept 0b. Slope-intercept form enables us to easily determine the equation of a line from its graph. Let's look at the examples shown on the coordinate plane. First, look at the red line, and note that it passes through the point 0, 2, as well as the point 3, 4. Moving from left to right along the line, we see that we have a rise of 2 and a run of 3, resulting in a slope of 2/3. We also note that the y-intercept is the point 0, 2. And substituting into slope-intercept form, y equals mx plus b, we obtain the equation y equals 2/3 x plus 2. Now let's look at the blue line. Once again, we can identify 2 points on the line, -1, 1, and 0, -1. And then note that the rise in this case is -2, since the line is sloping downward from left to right. And we have a run of 1. So the slope of the blue line is -2. The y-intercept is 0, -1. So its equation in slope-intercept form is y equals -2x plus -1, or simply -2x minus 1. We can also use slope-intercept form to write the equation of a line without having access to its graph, as long as we know the slope and y-intercept of the line. Let's look at 4 examples. First, let's write the equation of a line having slope -2 and y-intercept 0, 3. Remember that slope-intercept form is y equals mx plus b, in which m represents the slope and b represents the y-coordinate of the y-intercept. So we can write the equation of this line as y equals -2x plus 3. Let's move to example 2. We have a slope of 1 and a y-intercept of 0, -4. This leads to the equation y equals 1x plus -4. Or since 1 times x is just x, and adding -4 is the same as subtracting 4, we can just write y equals x minus 4 for the equation of this line. In example 3, we have a slope of -3/5 and a y-intercept of 0, 0. In this case, slope-intercept form would be y equals -3/5 x plus 0, or more simply, y equals -3/5 x. And finally, example 4, we have a slope of 0 and a y-intercept of 0, 2. This leads to the equation y equals 0x plus 2. But 0 times x is 0, so we could write this equation more simply as y equals 2. Note that this is the equation of a horizontal line, which is what we expect since the slope is 0. We can also reverse this process and identify the slope and y-intercept of a line when given its equation. Let's look at several examples. First, the equation y equals 2x minus 3. Comparing to slope-intercept form, y equals mx plus b, we see the line has a slope of 2 and a y-intercept that is the point 0, -3. Let's move to our second example, y equals -1/4 x plus 5. We see that this line would have a slope of -1/4 and a y-intercept of 0, 5. Equation number 3 is y equals x plus 4. Note that the coefficient of x in this case is 1, so we would have a slope of 1 and a y-intercept of 0, 4. Equation 4 is y equals 2/3 x. Note that we could, in slope-intercept form, write y equals 2/3 x plus 0. So the slope of the line is 2/3, and the y-intercept is the point 0, 0, the origin. In equation 5, we see y equals -5. Rewriting in slope-intercept form, we would have y equals 0x minus 5. This means the slope is 0, and the y-intercept is 0, -5. Note that since this is the equation of a horizontal line, we expected to see that the slope is 0. Finally, in example number 6, note that the equation 3x plus 2y equals 6 is not written in slope-intercept form. So in order to identify the slope and y-intercept of this line, we first need to isolate y by subtracting 3x from both sides to obtain 2y equals -3x plus 6, and then dividing by 2 on both sides to obtain y equals -3/2x plus 3. Now that the equation is in slope-intercept form, we can see that the slope of this line is -3/2, and the y-intercept is 0, 3.